Next up, mechanisms of persistent trains lifetime, Nagatoshi Nogami.
Does it work? Okay. So good day, everybody. This is my presentation. The title is, sorry. The title is Mechanisms of Long Life Emission of Meteor Persistent Trails. So I'm not a professional, I'm amateurs, but I was a chemical engineer. So I have a base of the some, say, spectrum and material science. So from my point of view, I talk about and now a new proposal for explanation of the persistent trails lifetime, okay? So first, maybe everybody knows about trails, meteor trail, okay? So usually most meteorite has a very short lifetime trails, like less than 1 second or so. But some of the meteors has a much longer lifetime of the meteor trail. Okay, so sometimes a few seconds, few seconds or a few minutes, or in case several minutes has the very long lifetime. So when we consider the lifetime mechanisms of these trails, so far some researchers propose a mechanism by from the spectrums, okay? So meteor emits a light of air component plasma heated by its ablation shock wave. So usually, when we talk about trails lifetime, these spectrums comes from the air component plasma. So just in the ablation, the shock front, there is a mix of very high temperatures. And then these plasmas emit light. But the spectrum of meteor trail often indicate its component metals. So not only the spectrum originated from the atmospheric components like nitrogen or oxygen, something like that, but also some case the metal oxides components spectrum detected. Most of their lifetime, most of their lifetime of a very short time, like a few seconds at longest. But some grow a longer time and a few 10 minutes long. So then the characteristics I'd like to summarize here. These long persistent trails, emission ablation altitude is about from 90 kilometers to 8 kilometers. And duration time, more than 30 seconds here, we say long lifetime persistent trails. Spectrum contains molecular bands of metal oxides, sulfides, and cyanide, and so on. So these kind of the results of the spectrum, here my co-workers, Shinsuke Abe and Peter Geneskens and so on, these peoples getting the result from these spectrums. So proposed light emission mechanisms so far, all these proposed mechanisms by any chemical reactions, atmospheric components, or chemical reactions of metals from meteorites and air. But none of them can give any answer to this long life question. Well, their proposed mechanism is, these mechanisms is not all, just only a small, limited parts of the mechanism. But anyway, all mechanisms have a very short lifetime. Usually a microsecond or millisecond at longest. Yeah, no approach to the second, 1 second. So the mentioned elements, in case metals, iron, sodium, magnesium, calcium, and so on, metal oxides, these metal oxides, and also few case no metals, oxygen, and like that. They are generated as meteoroid minerals vapor, or plasma by high temperature ablation heat. So vaporization behavior of metal oxides so far sometimes may be a key point of this explanation of spectrums, but we cannot give answer from these mechanisms. So okay, so when I go back to the beginning point to rethink the persistent trails. What is persistent trails? Okay, lifetime of the chemical reactions gas species are very short, in order of around micro or less than milliseconds, and the atom or molecule ion. But their trail keeps its tube-like shape with twisting behavior by wind at upper altitude. Okay, so when we see the persistent trails, its behavior along the trajectory of the meteors still emitting light, okay? So they don't disappear soon like gas. Not gas, but their trail look like smoke. What is smoke? Smoke must be condensed phase, from the material physics. It's called condensed phase microcluster or dust, small particles. So I mentioned that the condensed phase, it contains liquid and solid. So when we burn the organic materials like paper, clothes, or wood like that, we can get, they generate smoke. These smokes consist of the tar, very carbon content, thick carbohydrate. So the wooden smoke has the sticky liquid tar, but small size. It looks like, it behaves like solid. And in case of the burning of the metals, like ancient times photograph flash, magnesium, aluminum burned, and very white smoke they generate. So this, the smoke consists of the small size solid particle. Okay. And condensed gas generation at meteor ablation, condensation, and probably some of them melt by the high temperature. But after that, they will recrystallize the vapor chemical species from the meteorites. And stripping off the separation of non-metal mineral grains from meteoroid surface by ablation heat. So most of the surface of the meteoroids on the ablation probably are melted, not probably melted, mostly melted, because the fusion crust has a very good proof surface will melt. But this meteoroid body doesn't consist of the single crystal. Multiplied, some grains contains a kind of the heterogeneous, not homogeneous structure. So during the ablations, some piece of the small grains will split it off without melting, or some melt portion. Okay, so some melts generate as a glassy phase. Okay, so these small particles, sometimes we can say dust, may generate this kind of dust contained in the smoke. So dust plasma thinking way is have already proposed by Kelly 2004. But this case is just only the possibility of that, the aberration portion. Okay, light emission from small solid particles, is it by their black body? So at first, I think that these kind of the small solid may have the light emission by black body, the other black body from the thermodynamic physics. But sorry, no, they cannot emit light at low temperature, like around 300 Kelvin. So the experimental observations results, IR spectroscopy of persistent Leonid strains by Russell and so many peoples, and also by Shinsuke Abe and Peter Janiskens mentioned that very low temperatures, like standard temperature, or in case more than lower one, 200 Kelvins, even though their emissions still remain, we can see that persistent trails. Then by a kind of luminescence, yes, so we cannot explain by the black body, so we propose a kind of light emission. The solid can emit light? The answer is yes. I found that phenomenon. So the luminescence, here I described fluorescence, but it's a very, the definition of terms meaning is a little bit complicated. So I unified, called luminescence, okay, light emission. I call luminescence only here. So luminescence is the materials gained some energies. The energy is very variety. They have a variety of the energy kind. Heat case, electromagnetic field, or sound, or mechanical force, or chemicals, chemical reactions. And then inside of the materials, the electron excited and coming down to the ground state again, then the materials emit heat, photon, and electron, and so on. So this behavior is the very important possible candidates this time's explanation. So in gas phase, like plasma, the exciting processes from ground state and up to excited level and come down to the ground state again. So then they emit light. So this is the gas phase. Because gas has the, within a molecule or atoms, this process is very short time. But in the case of solid, this, the process is a little bit similar, but different. Because the solid has the electron, and the excited position is the crystal lattice. So that the electron excited at the crystal lattice and coming down to the ground state. So this is the interaction of electron and crystal lattice. That is the key of the long lifetime of the this process. Yeah, so in the end, yeah, this is the much more precise diagram. So Frank Condon process. Okay, so if you have a interest about that, I can explain later in much more detail. So anyway, in the minerals of the meteorites, we have, we have the kind of defect structure related to that phenomena. So there is one proof. This is the chondrite. Chondrite can emit light like this. So the mechanism is this, my proposal. Okay, so precise explanation later. Please discuss me. This is my new proposal. Thank you very much.
Thank you very much. I may have some questions for you later, personally. Does anyone have a question? Okay, I'm going to follow up with you later on that.
Yeah.
Very interesting. Thank you.
Thank you.